Welcome to beautiful Boulder. Located at the foot of the Rocky Mountains, the University of Colorado Boulder has an awe-inspiring view from campus. Innovative academic programs, hands-on opportunities, and rigorous coursework will prepare you for a complex global society. Ranked 34th among best engineering schools in the nation, the College of Engineering and Applied Science offers the top-ranked programs in the entire Rocky Mountain region. Ranked 40th in graduate computer science programs in the nation, faculty, staff, and students of the Computer Science Department are engaged in cutting-edge research projects that address some of the most important challenges facing society today.
Welcome. Thank you for your interest in the Computer Science Department in the University of Colorado Boulder. Our department has a long history of advanced research in computer science, including areas like artificial intelligence, programming languages, operating systems, and human-centered computing. Our department is situated in the University of Colorado, which provides a wonderful setting for interdisciplinary research as well. Graduates from our program have gone on to successful careers in academia and in industrial research labs, where they take the skills that they've learned here and apply them to problems in the real world. I hope in the rest of this video that you learn all about our department and join us in the future.
There are 4 important factors to make your graduate studies successful and joyful: faculty, graduate program, job opportunities, and the quality of life. And I'm proud to say that we are strong in all 4 aspects.
We have excellent faculty in our department. Our faculty have won many awards and recognitions nationally. Our PhD students have done very well as well. We have PhD students with awards like the NSF Graduate Fellowship, the NASA Space Technology Research Fellowship. We also have students who have won awards like the Ball Cells Fellowship, the Homeland Security Fellowship, and internally we have students who have won the Chancellor's Fellowship, which is the highest award given to students on campus.
I would say, for me, one of the most interesting parts, or one of the coolest parts about being here is the faculty. And apart from the fantastic faculty we have here, you learn so much from your colleagues. We have a very diverse set of students here in the graduate program.
One of the great things about coming to University of Colorado is the diversity of research and the amount of different fields of research that are going on here at the university. And that corresponds to a great deal of coursework and classes where you can kind of explore your interests and find, possibly new areas of interest than you had previously thought of.
NASA is actually pretty much ready to venture very far out. We have a NASA grant on doing research on the fundamental challenges in manipulation and perception for growing food.
So at the Corel Robotics Lab, we work primarily with swarm robotic systems in addition to humanoid robots. We look at swarm algorithms for task allocations and other sort of things interesting in the swarm robotics.
This is a small robot that we developed in-house to be as cheap as possible. We use this to test swarm algorithms in real life, whereas most other labs just do that in simulation.
Machine learning is how computers become intelligent, how they interact with the world and do amazing things like drive cars, detect whether an email is spam, and figure out when someone is being deceptive or lying on an Amazon review. Most people think about machine learning as a black box. It's something that does a useful task for them. What we're doing instead is trying to figure out how people can incorporate machine learning in their daily lives. One thing that's particularly fun to look at is games between humans and computers. We play games like Quiz Bowl, trivia games, where a player has to interrupt a question when they know the answer. We've successfully played against a number of opponents, including the highest winning Jeopardy champion, Ken Jennings. We beat him 300 to 160.
I'm working on helping computers to understand human language. The first step is to help the computers understand words, and based on its understanding of words, we can help the computers to understand sentences and documents and etc.
I work in a research lab that does lots of artificial intelligence. We are working on a lot of things, and one of the things that I work on is question answering.
So as someone reads you a trivia question, you start thinking about the answer. And we're working on making algorithms do something very similar to that. That like humans, they can think as you get the question.
Our main goal in CLEAR is to try to do a better job of getting the computer to produce an automatic representation of the meaning of a sentence. And we want to do this because it's going to really help us do a better job of machine translation, of communicating with robots, of automatically processing patient records so that we can get information about patients' timeline, what happened to them, what treatments were they given, what were the outcomes.
I am working on designing techniques that help people understand large document collections better and faster. To do this, I am using machine learning algorithms such as document classification and topic models. I am specifically interested in incorporating user feedback to help improve these algorithms.
I build data sets that we use for natural language processing in order to teach systems how to understand language. An exciting project we're starting sort of underrepresented languages in Africa, and we're studying just how to leverage what we know about English in order to automatically figure out how these languages work and understand their meaning.
I work in software engineering, I work in crisis informatics and human-computer interaction, and I'm really interested in the intersection between these fields. So how do you as a software engineer design and build systems that will actually be used by people and emergency management during disaster events? So this is our event editor. This allows analysts to create collections for the disaster events that occur. These are all of the active events that we have that are currently collecting.
So as software engineering researchers, we need to investigate many software engineering related issues. For example, how to model the data behind the scenes, how to integrate different software technologies to serve our need, and how to build clear interfaces to be used efficiently by our analysts.
We are using big data and computational tools to look at a variety of issues that impact people. And one of the projects that we're working on is the Tactile Picture Book project. And there we're looking at how to use computational tools to enhance and make 3D modeling more accessible, as well as impact how 3D printing can be used.
I work in what is popularly known as chaos theory. More appropriately, it's called nonlinear dynamics. And here's an example. This is a simple chaotic system. It exhibits what we call sensitive dependence on initial conditions, but there's some structure. I'm interested in understanding, modeling, and predicting systems like this and turning that to advantage for engineering designs and for predicting important things. Perhaps the mother of all dynamical systems is the one we're sitting on, the planet Earth, and it has all sorts of interesting regimes. You may have heard of the glacial and the interglacial transitions. And I'm also interested in working on time series data from the Earth to understand and perhaps predict those kinds of transitions. And if any of that sounds interesting, please come talk to me.
So the Ninja Car project is basically a smaller scale of a real car that we are trying to drive it autonomously in a harsh environment. For example, situations like a snowy street or a wet street that are slippery. The car needs to be capable of taking control of the hazardous situations.
So I'm working on the visual aspect of the car, so it has 2 cameras on it, and the goal is basically to take the video feed from those cameras and figure out where the car is and map out its environment.
My research is mostly focused on an area of robotics called the SLAM, which is simultaneous localization and mapping. So it's a robot walking around an environment, and it has to simultaneously map out that environment and figure out where it is in the environment.
I work with Project EPIC, that is empowering the public with information in crisis, and we studied the role that social media and social computing platforms play in disaster response.
I'm interested in how people come together on social media in disaster. What that means is how these emergent groups form in crisis, and also what kind of structures come out of these situations.
One project that I'm going to be working on is looking at images that people shared on social media during the Nepal earthquake that happened in April 2015. And what I'm interested in is what kinds of images people who are local to the earthquake shared versus images that the news and media and the global public shared.
We conduct a wide range of exciting research. Some of the examples of that research include software-defined networking, which Professors Eric Keller and Sang-Tae Ha are working on. Professor Dirk Grunwald is conducting research in wireless spectrum management using drones, and I'm conducting research on elastic sort of operating systems for the cloud. I also work with Professors Shiv Mishra and Christine Liu on systems to support mobile group recommendation and also systems to support cyber safety, specifically cyberbullying in online social networks.
So in the system lab, we work in a variety of aspects of real-world system design. So one of the problems that we are interested in the system lab is misbehavior detection and cyberbullying detection.
I'm working on a project called ScaleOS. ScaleOS is about making Linux kernel resources used more efficiently in the cloud.
Our work in the Superhuman Lab is dedicated towards making user interfaces more accessible, both universally and to people with impairments and disabilities. We are working on various projects related to perception of wearables and 3D printing and also robotics.
My work here is related to making 3D printers more accessible to people in general, to make it more useful in our day-to-day lives.
An exciting aspect of our lab is that I get to work on developing software that helps people reach their full potential, helps people learn better. So there are a lot of aspects of learning that are unnecessarily difficult.
Our overall theme of our lab is that we try to develop or optimize human performance given some cognitive model that we have.
This is the Programming Language and Verification Lab at CU Boulder. We specialize in programming language design and verification of programs to make sure that they meet their specifications.
A lot of my research is about checking correctness of software that interacts with the physical world around it. So these are called the cyber-physical systems. So a lot of my research happens to do with dynamical systems. I look at differential equation models, and I also look at software systems that work with these differential equation models. So the artificial pancreas project is the latest and greatest exciting project in my group. So there we are working with people in the medical school to verify a device called the artificial pancreas that tries to control how insulin is infused to people with type 1 diabetes.
What we're focused on is developing computational solutions and applying them to the design of new technologies that can help provide assistance to people. Our work ranges from looking at how we can integrate consumer devices like cell phones with advanced robotic technologies, to designing technologies for space exploration, to looking at wearable technologies and things like augmented and virtual reality for the workplace. There's a famous quote that the best way to predict the future is to create it, and that's really what we're all about here in my lab.
Here at the Iron Lab, we're working on a new project called the Data Fusion Project. It's all about sensors, gathering all kinds of sensor data, and it could be consumer sensors or robotic sensors, and be able to create a complete data-fused representation.
It's been really great 5 years. I've learned so much. It's been like a great amount of collaboration with students, with professors, I've gone to different conferences around the world, like Rotterdam.
One thing I love about working in the computer science department is that there's lots of interdisciplinary work to be done.
The faculty here is very involved in both academia and the industry.
I came here as a master's student, but I really like this place and I thought that this is a great place to do more research.
Boulder has many startups and robotics companies in which it's very easy to collaborate with them, and also that advances research considerably.
The professors that I work with are top researchers in human-computer interaction, so I've gotten lots of great advice and taken really great classes with the professors here.
People are very motivated and passionate about the technology that they work on.